Hey everybody, welcome back to the channel. Today's video is inspired by those on YouTube that show you how to wire up your train layouts in my profession as an electrician. So today's video, we're going to wire up your train layout based on the viewpoints of an electrician. So I'm not saying that you need to have an electrician to wire up your layout, but it would be nice to have someone with a viewpoint that can show you how to wire up your layout effectively so that it operates efficiently. Now as a group, we like to share and give ideas to each other to help us to get our layouts going, from the size wires that we run to connecting everything together. But sometimes simplicity is not always the greatest thing because it can lead to problems in the future. In my 19 years of being a state certified journeyman electrician, I have mainly worked in the industrial and commercial sections of the trade, a small handful of years in residential. I have worked in municipalities, pharmaceuticals, and laboratories. So I have installed and troubleshot lighting, motor control centers, switchgear, transformers, electric panels. I mean, anything that has electricity that runs through it, I can work on it. Now in this video, I'm not saying that my way is going to be the right way, but it will give you something to think about on how your layout is wired and possibly think that, hey, maybe I may have a problem with this and this might correct it. Now I know a lot of you have had your layouts running for the last 5, 10, 20 years or so and say, hey, well, I did it this way and there's no problem. And that's perfectly fine, it's okay. But this video will just give you something to think about. The structure that you see above my head is a partial train table frame that I have mounted to the ceiling of my basement. And we're going to do some of our wiring on this frame to show you how wires can be ran and tied together. So let's get started. Before we start the video, I'm going to show you my layout's wiring. Now my table is only temporary and it's only just to get the trains running. However, there are things I have done here that goes against my electrical beliefs. So I know that it can cause a problem, but again, this is only temporary just to have fun. So right now, with the wiring on my layout, I have these wires, they are soldered onto my rails. So this gives a nice solid connection, and if you take a Dremel tool, just clear away any coating or any corrosion that might be on here. You can solder these wires on here, and you want to have a nice connection on here, so in case if there's a derailment, you don't want the solder to melt, removing the wires off the rails. Now we see here that we have a set of wires going underneath the tracks and potentially underneath the ties. This I know is a no-no, because let's say if I was to take this wire and bend it at a 90-degree angle across this tie, the vibrations from the trains can dig into this conductor and create a short. So this I know is a bad thing, but you know, again, just to get something going. And if we look here at the back of my ZW transformer, wire nuts, wire nuts, wire nuts. I know this is a rat's nest right now, but again, all these connections, they are all secure. There's no problems with this, and everything works the way that it is supposed to be. And if we go here underneath our table, we see that we have these staples, and my conductors are free floating under here because these are MC cable staples. Now these staples is meant for MC cable for doing commercial wiring on a wooden frame, and I chose these because these staples do not have any sharp edges on them, and they will not cause any damage to this PVC jacketing of this wire. So what do these staples look like? Well, here we have a Romex staple, and you could tell that it is rounded all the way around and it's used for wire protection. And here we have the MC cable staple. It's a bit more thicker, a little bit more longer, so it can get deeper into the wood, because when you get that wire in there, it's going to occupy a lot of space. Again, both staples are round and they will not create any cuts or nicks in the wire unless you hammer them in deeper than they are supposed to go. So this structure that I have next to me is a train table frame that I have mounted temporarily up on the rafters of my house. And it's a lot easier for me to go through with this while it's elevated instead of cramping myself under the table and explaining a lot of things. So here we have our main frame. It's made out of 2x4s, and our main frame goes 8 foot long while we have 4 foot cross sections supporting the other edges and the middle of the train table. But right now I do have just 2 foot pieces made up as for demonstration pieces only. So let's say that we have our plywood here just for show, that we have plywood right above us, and we have our wires that are going across to feed our accessories, to feed our track, and they are shown that they're stapled up, and we have our first connection here. And this just seems like a basic wiring that I have seen in a lot of these layout wirings. And it seems pretty common that this may be a traditional way how to wire up your layout. But right now, I found 4 problems with this, with all this wiring that is not good for your layout. The first problem that we have are these arrow staples. When they come out of an arrow staple gun, they immediately pinch on the wire, which can also start piercing the jacketing. Now, since that this is a PVC coated wire, it didn't do much damage or any damage at all, but over time, through tension and vibration, it can dig into the insulation. And yes, when you run your trains, the table vibrates so slightly, and the AC frequency going through the wires does add vibration to this too. So in time, it's possible that this wire is going to short out right on the staple. Another problem that I see is that these port connectors are becoming increasingly popular with model railroaders. The problems with these is that these are made out of plastic and can crack, and they're not guaranteed to hold all the time. And however they're made, these things can fail. I have worked with other foremen, and I've worked with city inspectors, and they say that they hate these things. They do not like these because they do not make a positive connection. Plus, if they're not connected right, and depends on the internals of this, these can heat up, create power loss. The fourth thing is, this splice is in the air. And what happens if you need to pull some wire towards you just to get enough to make another splice? What's going to happen? You're going to pull on these port connectors. And this is potential for the wires to come out of these connectors because you're putting tension on this. So you have no support with this splice whatsoever. Oh, and by the way, the person that opted to use these, they said that wire nuts are not secure. Well, obviously, they don't know how to use wire nuts properly, and I will show you how to do that later. Another problem that I see is you look at these wires, and there is a great distance with this wire that is not supported. When you have wire like this, and it is not supported, it creates tension, and that tension could go back to the next attachment point, which is shown here, and this is already digging into the insulation. If I can get close enough and just brighten that up a bit, you can see that staple is now digging into that insulation, and this can cause a short in the future. So these are the problems that I see in a lot of these layouts, that people don't know that they have problems, and then they have to go back and rewire their layouts or accessories or something. But it's not anybody's fault that they don't know these things. So I want to try and show you the proper way how to do this. And it may seem excessive, but you know what? It'll give you something to think about. So how much force is exerted on the wire going across table? We're going to use our fish scale to find out. So this wire that we have just dangling, that's the wire that I just showed you, that's anchored to the staple on that 2x4. We're going to turn on our fish scale, let it get started, and we're going to bring it up to the staple that we had right here underneath. And we're going to put pressure on that to make it look like the wire that I was giving the demonstration in. And as we bring it back, we have over 3/4 pound of pressure exerted on this wire between the two staples. That is a lot of force to put on this wire at these sharp points on the staple. This wire will dig into your staple at the corners and will create a short in times. Another type of connector that I have seen on layouts is a tap connector. This is a tap connector, and its purpose is to clip onto an existing wire and have a leading wire come out from the fork end of this out through the head of the connector, so that it can go to your track, power, to your accessories, or anything of that matter. Now, I've seen these for the first time and in my apprenticeship, where they were used in a contactor cabinet for a conveyor system, and I was asked to replace these because all these burned up. And that's because that these guys don't always make a 100% connection with whatever you are tying into. So how these work, it's very simple. We just take our number 12 wire, and these can go up to number 10 wire, I believe. And you want to get it into that V channel of the tap. You're going to want to apply some pressure to get it in there, and you have to pierce the insulation to make connection with the copper conductors. Now it is rather hard because we have to pierce the insulation, and you can close this and try and force it closed and get it on there. But I'm going to take my needle nose from my strippers and I'm going to force it into the groove of the tap connector. And after forcing the wire into the tap connector, we can see that it is fully seated by the nylon jacketing sitting on the edge of the butt of the plastic housing. And from this, when we get it all done, we can take it and close it up. But again, how much of this copper wire is making contact with this V-groove? And let's find out. So we're going to pull this out. With the wire zoomed in, we could pull back the jacket on the wire and we can see some exposed copper. So we have a couple strands on this already cutting into the V-groove, which could be maybe 2 or 3 strands at best. And if we flip this over to the other side, probably have 1 or 2 strands by itself. Now, even though that we see 2 strands available, it doesn't guarantee that it's always making a 2-strand connection, because depending how the wire is twisted, you could be making just 1 connection on this piece of wire right there. And over here, we could be making 2-strand connections as far as I know. Let's strip this and see how much wire is making contact with that groove. Here we can see where the V groove of the tap started to dig into the copper conductors of this stranded wire, which is not good because that could also reduce the conductor count of your wire, making your wire smaller. And if we flip this around, we can see where the other groove grazed the edge of the copper here as well. So this type of connector is not good because it just doesn't make a fair connection and can potentially break the strands in your stranded wires. So I would avoid these connectors and taps altogether. In the upcoming segments, I will be showing pictures and videos of problems that I have encountered on the job site while running this job. Now granted, I can make repairs to the electrical equipment that I have installed. I cannot make electrical repairs to equipment that other contractors have installed, like HVAC equipment, as they have warranties through the HVAC contractor. Now while I do provide power, I have to run my wires into their control cabinets, and I see that they use that the manufacturer uses port connectors to distribute power and communications throughout the system to make it work. And I say I'm not fond of those connectors, and here's why. This HVAC unit has a bunch of these port connectors installed in them. I chose to remove this 2-port connector in front of me because it was the easiest to get to. And looking at the yellow wire, we can tell that there are several strands of the copper wire pushed back against itself, reducing the connection on this circuit. Now granted that this may not cause any problems, but it does go to show that user error is involved with this, and the potential to lose connection increases while using these connectors. Now there is another way that you can lose connection inside of your port connectors, and that is if you install it properly. Here's what can happen. So right here, we're going to get some nice zooming footage of this. We have a number 12 stranded wire here, and we could tell by the number 12 shown right here, that's 12 American wire gauge. And this wire is what I commonly use as an electrician in the field, and we can see that these are the copper strands inside the wire. And I'm using needle nose to represent my port connector because the port connector just squeezes down on the copper strands of the wire. So I'm just going to stick them in probably about yay much or so, and I'm going to give it a nice crimp. Now this is what happens inside of your port connector. So the wires you see are flat smushed down inside, but is it really making a 12 gauge connection? So I'm going to use my Acne needle tool, and I'm going to gently pull back the strands that are on the outside. And if you can see what's happening, that this is not a good connection. And again, I'm not putting a lot of pressure on this, just enough to move the wire that's not connected. That's in there. It's another strand. And
blatantly, this is the reason why I don't like these things. So if I pull these apart, remove the needle nose pliers, look how much wire is not connected inside of that port connector. And look how much wire is making connection. And again, this is if you properly installed it. I just turned my 12 gauge wire into a 16 gauge wire. This will not handle that high current that your trains may possibly need. So this is why I avoid these connectors altogether.
Also, if you look at the wire inside of the port connector, you can see that those strands of wire is kind of spaced out. That itself is a poor connection. You want to have wire that's twisted tightly together for proper current transfer so that there's no heating up whatsoever. Something like that will cause the connector to heat up and break in the future and possibly damage the insulation of your wire at the connector. Now, some would say, why not just use solid wire? The problem with solid wire is that it is a rigid wire and it has to go straight into the port connector. The other problem I see is that the contact surface between the solid wire and the port connector is going to be very minimal. Let's just say that we have a train wheel sitting on a rail. That train wheel is going to represent our 12 gauge wire while the rail represents the contact surface of the port connector. Can you see a lot of power being transferred from the wire to the port connector? I can't, because that contact area is very small. I have the Great Northern Empire Builder set, and that draws 7 amps of current on 14 volts AC. I can't see 7 amps of current going through that small contact surface. Now some would say, well, how about we just twist the stranded wire together, or just put some solder on it and put it in the connector? Well, let's go back to my conversation with solid wire. So what are some of the things that I have seen people use in their videos that I like a lot? Well, a copper bus wire system, a terminal bus, if you can see these, fork or ring terminals, wire nuts, and track pliers. The first thing that I'd like to talk about is a bus wire system. This is a great way to distribute power onto your layout while minimizing voltage loss so that your trains can run smoothly around your layout. Now, your bus wire is basically a larger wire that comes off your transformer, goes around the perimeter of your layout, connects back to your transformer, while 16 or 18 gauge wires are tapped off these wires and go right to your tracks. And you could tap every 5, 6, 8 sections of track just to reduce the voltage loss on your tracks so that your trains can run more smoothly. Now, I've seen you guys out there run 18 down to 10 gauge wires for your trains and accessories. And the way that the wire is gauged is that the smaller the number, the bigger the wire is going to be, which means it can handle more amps and it's also more conductive. Now, what that means is, let's say if we take 1,000 feet of number 16 wire and 1,000 feet of 12 wire, if you were to take a digital multimeter and measure the ends of the wires, you'll find that the number 16 wire has more resistance than the number 12 wire. Now, your bus wire is going to be determined on what you are putting on your tracks and how big your table is. So if you just have a train table in your basement or in your garage, you could probably get away with either 14 or at the biggest size 12 gauge wire. And this will help be a bit more conductive in those longer runs so your trains can run better. But if you're doing like train show status where you have one of those big tables, well, for me personally, I would run 10 gauge wire just to reduce the voltage loss, because bigger wires are more conductive and they will help reduce the voltage loss on any kind of electrical equipment. Now, each wire is going to have its maximum allowable ampacity rating. And the chart that I'm going to put on screen for you right now will show the maximum value of current that we could put through these wires. Now, granted, you never want to be at these ratings, because if you are, the wires are going to start to heat up. Where they're connected to is going to start to heat up. The circuit breakers in your transformers are going to start to heat up, prematurely trip, and they're going to prematurely fail. Now, granted, you're never going to put 20 or 30 amps through a ZW transformer, but this is what the values are. But these larger wires are mainly for if you have a voltage loss problem on your layout. So how do we take care of this current problem? What is the maximum current that we can put through this safely? In the trade, we have what's called the 80% rule. So we take 80% of the maximum current ratings of these wires and we bring them down a bit so we can reduce the temperature at your connectors and circuit breakers so that our equipment can operate effectively and efficiently while maintaining a cooler temperature. These terminal buses are excellent because they keep your wires organized, neat, and great for distributing power. Let's go over a few tips with these. So I got my terminal bus from Amazon, and this guy here is 15 amp rated. Now, of course, you never want to go with the full 15 amps across this because these terminals can heat up, and with the thermal differences of heating and cooling, along with the AC voltage, current and vibrations of your train table, these screws can loosen over time. So I do apply the 80% rule to these terminal strips to help them run at a cooler temperature so you won't have any bad connections in the future which can burn up your wires and these terminal strips. These strips, they do come with, these buses, they do come with these fork terminals, so you can power up the entire bus, or you can cut these to whatever you want to operate, maybe just 2, 3, or 4 of these at a time for your trains or accessories. No, that is completely up to you. If you do need fork terminals, I would recommend going with the manufacturer recommends, because this guy I got from Home Depot and Lowe's or Amazon, and these are pretty basic fork terminals. And this one here meant for 14 gauge wire, I had to kind of collapse in a bit and make it shrink so that it can fit underneath this screw terminal. And this could be a potential bad connection in the future, so I would not do that. Now you can put wires in directly into this, and here we have these 2 red wires are 14 gauge wires, and I would recommend you put them in underneath the terminal plates like this so that you have even pressure underneath your plates and your screws. Now, of course, it's small enough wire you can probably get away with 1, but the point is that you don't want to create any uneven pressure under the screw head, because I've had a few of these break in my career. So plus, you never want to torque these down too much because, you know, again, it can break the heads. And what happens if you use a larger wire like this 12 gauge wire? Well, you can see how the connecting plate is kind of cocked over to one side, and this is creating the uneven pressure underneath the screw head. And again, this is potential for breaking right there. So how do we fix this? We could put another 12 gauge wire right next to that, and that would take care of the pressure problem for this screw. Now, let's say if you had to put only one wire underneath this. Well, this 12 gauge wire, all we did is we forked the conductors underneath the screw terminal so that when we tighten this down, the pressure is even underneath the terminating plate and the screw, so this will not break at all. So how do we do that? It's very simple. Here I've stripped out about 1 inch of my 12 gauge wire, and I just took a small screwdriver and I just kind of separated the conductors evenly into this V shape. And then I took a small needle nose pliers like this, and then I just put them all the way to the base of the wire, and then I just made up my forking V terminal to go inside of the terminal bus. Let's move along to crimps. Now, using crimps is a great way to land our wires on the stud terminals because it helps keep a 100% positive connection on our switch tracks and on our transformers, so this way we can distribute power and controls evenly, reducing the risk of the wires coming off. Now, we typically take our wires and we make a little hook out of them, and then we tie them onto our stud terminals, but the problems with this is that when you screw down on the thumb terminal, all of these stranded copper conductors, they can fan out, and then they can make a loose connection, a very poor connection, and can eventually come off through heating and contraction and vibrations. So this is where we use crimps. Now, these crimps here are good for number 10, number 12 gauge wires, and can be used all the way down to 18 gauge wires. And I've used these earlier in my apprenticeship, which was great, but till I was told I was using them wrong. Now, as I'm told, and we're going to take one of these skirts off, that if you look at this crimp, you can see that there is a seam right here on the top side of this. This is where I was told that if we crimp onto this or anywhere else around, that this can create an irregular shape while you are using your crimping tool, and this can separate conductors on your wires and make a poor connection. So there is a right way and a wrong way to use these. So I cut up some wire, and we're going to remove all these skirts and show what happens on the insides of these crimps. Before we do any crimping, let's talk about the types of tools that we can use. So here at the house, I have these commercial electric strippers, crimpers, and thread cutters, and at work I have my Cobalt lineman cutters. They were strippers at one point, but they also do crimps as well. Now there is another crimper as well too, that it has the crimps at the end of the jaw like this for, again, various types, but I don't have that tool right now, so as these two I mainly use. So the first one that I did use was the commercial electric tool here. And if we open up the jaw, we could see that this is where the crimp section is, but it does have a small footprint, and you may have to crimp twice with this. So it's not a bad tool, but it's just more work involved. The tool that I do use for work, my Cobalt linemans, I don't know if it's going to be easy to see on camera, but if I get to that angle, you can see that the crimp dimple right here covers a lot more surface area than the tool I just showed you. So this will make it a lot easier to crimp, to crush down more metal, to do it one time, and plus comfortable handles is what you need the most when you are crimping. So let's go ahead and do a crimp. So when we're doing our first crimp, you want to keep the seam 180 degrees away from the dimple, because these seams on these crimps, they can break in irregular shapes and separate the conductors, which you don't want because it can make a poor connection. No matter how hard that you would crimp it in a wrong way, the wires can pull out. So I learned that in my apprenticeship, and you know, thankfully you have people that teach you, they help you along the way to make yourself a better electrician. So we're going to put this in with the seam facing opposite of the dimple, and I'm going to get a piece of wire. Now we're going to have the wire just sitting up right towards the crimp, and we're going to squeeze this in. Okay, so that wasn't a lot of work. It was actually, you know, comfortable to hold the tool. And here is our crimp inside. I'm sorry, here's our wire inside of a crimp, and you can see just how nicely uniform that is. And this is the stuff that you don't see behind all of these yellow insulating caps, because even if the crimp is bad, these will hide it and you may not see any faults that may lie underneath. So I'm going to go ahead and I'm going to use the other crimps in the other irregular fashions and see what comes of it. So I'm going to take another crimp, I'm going to install it kind of sideways, and we can see that the seam is right there, and we're going to install our wire. Okay. This is something you don't want happening, because look at that. That just separated right there, and this, you know, it looks like that it is an okay connection, but look how much of this is irregularly misshaped. So this can be a potential for a bad connection and can it pull off. I mean, something like this can, but if you look at the gap in the back of that, that's not a good connection. So doing it the first time, the way that I just showed you, is the right way to show you how to do this. And oh yeah, it did pop off. Yeah, look at that. Yeah, that didn't even do a good of a job. And I'll show you with my commercial electric strippers that this crimper here's the dimple, and we're going to put that with the seam facing upwards, which is the right way to do it, 180 degrees away from the crimping dimple. I'm just going to stick my wire in here, and I'll show you what this is going to look like. Okay, so I mean, it's not a bad connection, but you can see where it crunched in here with just that little footprint. So if I was to do this, which I've done in the past, I would have to crimp it once at the back and then once at the front, just to make sure that it is making a good connection. Now, even though it does kind of feel, yeah, it is tight in here because this is a uniform shape all around. Now, I do have one more crimp tool, and I had to go out to my truck and get it just to show you good people. And that is the 6500 series thrift crimp tool. This is a ratcheting crimper that you can use on solid and stranded copper wire, and it's a very simple tool to use. All you have to do is just put your crimp in one of these three chambers here, and all you have to do is just close down on the handle, and we can see that the jaw starts to close. You can let go of this and it will maintain its shape. Unless you have to reposition the crimp around, it does have a release mechanism, so we just pick that up and the jaws will open up. But mainly, all we're going to do is put the crimp in there with our wire. You hear that ratcheting action, and then you give it one good squeeze, and then it will automatically release after that. Now, I had to buy this tool because I had to do crimps on the solid wire. And the tools that I just showed you will only bend the metal of the crimp, but will not make any indentations on the copper, on the solid copper, because it's more of a solid metal. This is the only tool that I know of that actually worked for me and will keep the crimps on the solid copper wire itself. And of course, you could probably use it on stranded wire, just for a more solid connection. But either way, those tools I just showed you is good for stranded. Whether it's set up under the Christmas tree or set up in the family living room, eventually our trains are going to have to come down, unless they're mounted onto a table. But that also means we're going to have to take down our tracks too. And to get our tubular tracks apart, we're going to have to take them both in hand. And if they're fairly new or new tracks, we're going to have to give them a little wiggle to help separate them. Now this wiggling action is going to cause these pins to open up your tubular track on the female end. And that is potential for a lost connection the next time that you set up your tracks again. And every time that you pull them apart, there is a chance that it's going to have a greater lost connection. So how do we take care of that? Well, a few years ago up on eBay, I picked up these track pliers for about 12 bucks a piece, and this one's for O gauge and this one's for O27 gauge. And these are not the best in the market because they're rather small. The handles are really small. They do hurt your hands when you try and, when you do tighten down on the tracks to make a better connection. And you can see that this one here is just falling apart, and I did not have a lot of uses out of this. But it did its job in maintaining the track connections, but still, that these are not the greatest and I would not recommend them. However, the ones I would recommend is from HenningsTrains.com is their bullnose lineman track pliers, and these have nice comfy handles, a good grip on them, and you should be able to tighten down all the tracks that you want with these pliers. So go check them out today. So back to here, we have these track pliers, and we're going to do a small demonstration on how they work. And this is the back of our tubular track, and I have already done the outside common rails, and you can tell how nice and tight they are. But commonly that when we take apart our tracks, we can tell that the center rail can show what the excessive wiggling can do. So on this O gauge track, we're going to use our O gauge track pliers, and we're going to put the drilled section into the rail, and then we're going to give this a nice squeeze. And right here we can tell that the track has closed, and I want to move this back just a little bit, probably about the width of the needle nose, and then give those a nice squeeze too to give a better connection. Now I don't think that you have to keep the tracks in here to get a better connection, but I think that these pliers are made for the open rail so that you can squeeze the metal together. We're going to be talking about wiring up our layout in just a moment, but I hope that this video has been informative up to this point about possible wrong findings under your layout and bad connections, because we know that any kind of strained wire or any kind of bad connection can lead to a bad electrical operation in the future, which may cause you to rewire your layout or spend a long time trying to find the problem.